question 4 of the MTH312 Midterm 2. And we can see that this question says use Laplace transform to solve for f of t. And f of t here is what we call a Volterra integral equation. And so it's sort of a mix of a lot of the things that you learn. It includes Laplace, convolution. So let's jump right into it. So we want to essentially find Laplace of f of t. So you can just rewrite, we want to find the Laplace of f of t, which is equal to 1 plus t minus 16 integral from t to 0 of tau minus t f of tau d tau. Now, this right here, we could make our lives very easy if we are able to somehow manipulate this such that we are able to get a form of t of 0 f of tau t minus tau d tau. Because if we are able to manipulate to get this form right here, this is just convolution. And since we are taking the Laplace, don't forget that we're taking the Laplace of all of this. If you want to take the Laplace of a convolution, it is very simple. All you have to do to find the Laplace of the convolution of two functions, let's say f, g, it's just the Laplace of f multiplied by the Laplace of g. So it's a very, very useful theorem that can save a lot of time. However, right now as it stands, this is not in the correct form. We have tau minus t. If you don't read the question correctly, you may oversee this and think it's nothing, but it is in fact very different and will lead you to a wrong answer if you just go ahead and try to start and evaluate. So what we can do is, let's erase this. What we can do is, well, tau minus t, what can we do to turn this tau minus t into t minus tau? Well, if we take a negative out, this will leave us with what? This will leave us with negative tau plus t, or in other words, t minus tau. Right? And so, since we have a negative, we can just take this negative 1 that we have, we can think of it as a negative 1, we can take that constant, we can take this out of the integral. So this minus 16, if we rewrite it, let's rewrite the whole thing. We can take it out and it would turn into a plus 16 t of 0, and then now we pretty much have our form. You can just write f of tau, and then we have our t minus tau d tau. And now this is the correct form for convolution. And so now what we can do is we need to identify the two functions. Well, obviously the f was just f, and this function, we can call it g of t, or well, we don't even need to call it. This is technically just t. So the Laplace of f of t, the Laplace of 1, the Laplace of t, plus we can keep, we can keep our constant out, plus 16 Laplace of, since we recognize this from here to here as convolution, we can just rewrite it as the convolution of f of g, the Laplace of the convolution of f of g, where we have f and our other function is just t, as so. And now this question has become pretty simple. We know the Laplaces of all of these. We know that the Laplace of f of t is capital F of s. You know that the Laplace of 1 is 1 over s. We know that the Laplace of t is 1 over s squared. And now we know that the Laplace of f times t would just be the Laplace of f, which is just f of s, times the Laplace of t, and we know that the Laplace of t is just 1 over s squared. So there we have it. Now, what we need to do is we need to isolate and find, solve for f of s, which then we can take the Laplace inverse of f of s to find our f of t. That's what we're looking for. So let's go ahead and do that. What we can do is we can move our 16 f of s times 1 over s squared to the other side and group it with the other f of s. So this would give us f of s minus 16. Let's multiply the 16 and 1 over s squared times f of s. And it's equal to 1 over s plus 1 over s squared. And technically what we can do is we can merge these two by getting the same denominator. And so we would have to just multiply s here, and essentially we would get s plus 1 s squared. Now we can factor out the f of s on the other side of the equation. So this would leave us with 1 minus 16 over s squared equal to s plus 1 over s squared, which this, we can simplify that by getting the same denominator, and that will give us s squared minus 16 over s squared. We can then move this to the other side. And we can see that the s squareds cancel out. Leaving us with s plus 1 over s squared minus 16. And we know that s squared minus 16, this can be rewritten as a perfect square, and it would just be s plus 4 s minus 4. And this is our f of s. Now we need to find the Laplace inverse of our f of s, right? Because this will give us our f of t. So how can we do this? Well, what we can do is we can use partial fraction decomposition. Shouldn't be too bad. So technically, if we were to do partial fraction decomposition, we would have we would have s plus 1 is equal to a s minus 4 plus b s plus 4. I just skipped a little step, but you should be able to get this when you want to do your partial fractions. And then we can try for when a is equal to 4. Sorry, s. So that means 4 plus 1, that is equal to 5. 4 minus 4 times a, that would be 0 times a, so 0. And then 4 plus 4 is 8, so this would be 8b. b would be equal to 5 over 8. And then let's do at s is equal to negative 4. Negative 4 plus 1, this would give us negative 3. And then we have a, negative 4 minus 4 is negative 8. So we have negative 8a, and then b is just going to be negative 4 plus 4, which is 0 times b, 0. And so we isolate for a now. Our a is equal to positive 3 over 8. So we found both of our constants now. This would mean that we can find the Laplace inverse of a over s plus 4, which would have been 3 over 8 s plus 4 plus 5 over 8 s minus 4. And so we can split this into the Laplace inverse of, and let's take out the constants as well. 1 over s plus 4 plus the Laplace, plus 5 over 8 Laplace inverse of s1 over s minus 4 as so. And so 1 over s plus 4, this is pretty simple. This would give us 3 over 8 e to the power of negative 4t. And then the Laplace inverse of 1 over s minus 4 would give us 5 over 8 e to the power of 4t. And so this right here would give us our f of t, and this is how you solve the equation. So this is the answer.